Hello everyone, welcome back to the second lecture of chapter 22, Maintaining Air Quality for Pure Chemistry O-Level. Now, we should be on page 5 of the chapter 22 notes now. Now, in the first lecture, we learned about what makes up clean air, what are the percentage compositions of each gas in clean and dry air. So now let's swing to the other extreme. So we have heard so much about air pollution in our lives. You have heard that different cities around the world will be plagued with problems like polluted air, smog, haze. So let's learn about which gases are considered atmospheric pollutants. So let's learn this word pollutants. What on earth is this word pollutant? Now, atmospheric pollutants are gases which are harmful, to living things or may damage non-living things. When they are in high concentration in the air. So the idea is these are gases which are definitely harmful to the health of the living things, or they may be damaging to the environment out there when they are in very high concentrations in the air. Now, these are atmospheric pollutants. So naturally we come to the word pollution. So what is air pollution? Air pollution is the condition in which the air contains a high concentration of these chemicals or pollutants that may harm living things or damage non-living things. Now, this table summarizes a lot of information. So before you embark on the table, let me address this question: how to study best for this chapter. You are expected to know the sources, where each pollutant comes from, and the effects. What does each pollutant do to human health? Do to the environment? So you need to learn the sources and effect of each pollutant well. And you notice you may not be able to use your own words. You may not be able to deduce it on the spot without having learned it. So this table on page 5 has to be learned in great detail. Alright, so let's begin with the first pollutant. Now the first pollutant is carbon monoxide. Carbon monoxide, the mono indicates there is only one oxygen, monoxide. So therefore, CO is the formula, one carbon, one oxygen. Now, carbon monoxide source is actually the incomplete combustion of fuels. Alright, so incomplete combustion of fuels causes carbon monoxide to be formed. Now, what is incomplete combustion? Combustion is incomplete when there is a limited supply of air or oxygen. Whenever burning takes place, it needs oxygen. But what if the oxygen itself is limited supply? If the oxygen is in a limited supply, incomplete combustion happens. For example, in the engines of cars, there may be insufficient air, especially when the car is running at high power mode. It needs to burn a lot of petrol. To burn that amount of petrol needs a lot of oxygen. What if there's insufficient oxygen under the high power mode of the car engine? That will result in incomplete combustion of the petrol, and incomplete combustion of petrol would cause carbon monoxide to be formed. Now that we know the source of carbon monoxide being incomplete combustion of fuels, what are the effects of carbon monoxide on human health? You notice carbon monoxide is very damaging and harmful to human health because it combines with hemoglobin in the red blood cells to form carboxyhemoglobin. And this reduces the ability of hemoglobin to transport oxygen to the rest of the human body. Now, to this, let's add a few words. It reduces the ability of hemoglobin to bind to and transport oxygen to the rest of the body. So carbon monoxide poisoning is real. Carbon monoxide is quite lethal Just a little carbon monoxide in the air would already cause breathing difficulties. Why breathing difficulties? Because carbon monoxide combines with hemoglobin in red blood cells and it reduces the ability of the hemoglobin to bind to and transport the oxygen. And hence, people will experience breathlessness, fatigue, lack of energy if there is just a little carbon monoxide in the air. Okay, that's how carbon monoxide is harmful. Now let's move on. The next pollutant is sulfur dioxide, SO2, dioxide. So there's two oxygens, right? Di means two. So SO2. Now sulfur dioxide can either be man-made or natural. So the man-made source is the combustion of sulfur-containing fossil fuels. The best example is coal. So coal is a solid rock which can be burnt as a fuel. However, the problem is coal contains quite a lot of sulfur. So when coal undergoes combustion, burning, it actually releases sulfur dioxide because the sulfur reacts with oxygen to form sulfur dioxide. So combustion of coal very often results in formation of quite a lot of SO2. Now the next source of sulfur dioxide is natural. Natural means it occurs naturally without any humans. So volcanoes. When volcanoes erupt, volcanic eruptions cause the release of sulfur dioxide into the atmosphere. Okay, now important to take note, if you're asked for the natural source of sulfur dioxide, is volcanic eruptions. Volcanoes on their own don't produce SO2 until they erupt. So it's very important to mention eruptions. Okay, I'm saying this because a few years ago we said this for prelims. We asked the students what was the natural source of SO2. Many of them just wrote volcanoes, full stop. No, that's not correct. It's volcanic eruptions. The volcano has to erupt in order to basically release SO2 to the atmosphere. Okay? Now, before we go on to the effects of SO2, let's move on to the next pollutant, which is oxides of nitrogen. Now, there are two oxides of nitrogen that we need to know, NO and NO2. Okay, now they have common names. NO2 is called nitrogen dioxide because there's two oxygens, so NO2. NO is called nitrogen monoxide, but the common name actually is nitrous oxide. So nitrous oxide is NO, nitrogen dioxide is NO2. Okay, now oxides of nitrogen can either be man-made or from natural sources again. So the man-made source is the reaction of nitrogen and oxygen, but this doesn't occur naturally. Nitrogen, as we said last lesson, is quite unreactive because nitrogen has a triple bond between the nitrogen atoms. The triple bond in nitrogen is very difficult to break. You need a lot of energy to break the triple covalent bond in N2. Hence, for nitrogen to react, it needs high temperatures. So, oxides of nitrogen can only be produced if there's reaction between nitrogen and oxygen at high temperatures inside the internal combustion engine of cars. Okay, so here are the two equations. Now you notice, first the N2 reacts with O2 to form NO, nitrous oxide. The second step involves oxidation of the NO to form NO2. So the second step involves NO reacting with more oxygen, so NO is oxidized to NO2 in the second step. Now this occurs only at high temperatures in the internal combustion engines of cars. This is why if you have more cars, vehicles on the road, you actually result in more of the oxides of nitrogen being formed. Okay? Now, oxides of nitrogen can also be formed through a natural source, lightning activity. So when lightning flashes down the sky from the atmosphere to the ground, lightning activity is also able to produce oxides of nitrogen. Okay? In a sense, the lightning activity provides the energy needed for nitrogen to react as well. Now, Now let's look at the effects of both sulfur dioxide and oxides of nitrogen. The good news is the effects of sulfur dioxide and oxides of nitrogen are common, because sulfur dioxide and nitrogen dioxide, SO2, NO2, they are both acidic oxides. So let's recall, acidic oxides are non-metal oxides. Okay, so acidic oxides are non-metal oxides that can dissolve in water to form acidic solutions. So the solution formed after they dissolve in water has a pH value of less than 7. So sulfur dioxide and nitrogen dioxide, the dioxides, are acidic. Okay, and this is crucial because they are able to react and dissolve in rainwater to form acid rain. Okay, so the rain that falls from the sky becomes very, very acidic. The pH value can be as low as 3. Okay, and this is very harmful because it corrodes limestone and metal structures, and it will damage or harm aquatic life and plants if the acid rain enters the rivers, lakes, and seas. Besides that, because sulfur dioxide and nitrogen dioxide are acidic oxides, they can also cause inflammation of the airways, in particular the lungs, and breathing difficulties if they are inhaled. This is because the lungs is full of moisture, right? Most of you have learned in pure bio. The lungs have a film of moisture on their surface. So imagine if these acidic oxides enter the lungs, they will dissolve in the moisture to produce acidic solutions, which will cause inflammation, it will cause irritation, it will also cause breathing difficulties. Alright, so these are the main harmful effects of sulfur dioxide and nitrogen dioxide. Now notice how we are focused on the dioxides. How about nitrous oxide? You have learned that nitrous oxide is actually a neutral oxide, right? Meaning nitrous oxide actually does not dissolve in water. However, nitrous oxide is still dangerous. It's still dangerous because it still can form NO2, right? If nitrous oxide still can form nitrogen dioxide, this means that if I produce nitrous oxide, it could react with more oxygen to form NO2, which is acidic. So nitrous oxide is still dangerous, it's still a pollutant because it is able to react with oxygen to form more NO2, which contributes to acid rain. Okay? Now I know it's a lot of info, but we have already finished carbon monoxide, sulfur dioxide, and the oxides of nitrogen. At this juncture, it may be good to pause the video, reflect on what you have just heard and seen, read it once more, and see if you have questions to ask Mr. Soh. If there are no further questions, let's move on to the last 3 pollutants that you are expected to know in your syllabus. So the next pollutant is methane. Now for methane, you need to know the formula is CH4. You need to be familiar with the formula of methane, CH4. How do you draw CH4? I think it's very straightforward. This is how you would draw CH4. Alright, the molecule of CH4 has 1 carbon, 4 hydrogens. That's methane. Now methane is produced by decay of animal and plant matter. Alright, when we say animal and plant matter, we could mean dead animals and plants decompose. It releases methane. Besides that, the feces from animals can also decay to give methane. Alright, so that's what we mean by animal and plant matter. Besides decay of animal and plant matter, digestion of foods by cows and sheep can also produce a lot of methane. This is why, okay, generally speaking, the cow rearing, sheep rearing industry produces a lot of methane. Okay, now this industry is called the animal husbandry industry. In case you're wondering, animal husbandry industry. Now this is not husband like, you get married, you have a husband. It's not like that. Animal husbandry means you are actually rearing animals as a means of living. Alright, in particular, cows and sheep are the main contributors to the release of methane to the atmosphere. Now, methane is a very potent greenhouse gas. It's a very powerful greenhouse gas causing global warming and climate change. Alright, so often we think about carbon dioxide as a greenhouse gas. However, methane is also a very, very potent and powerful greenhouse gas. In fact, methane is estimated to be more than 100 times more potent than carbon dioxide in causing global warming. Okay, so this is not to be ignored. There is more than one type of greenhouse gas. Next, we have unburnt hydrocarbons. Now, unburnt hydrocarbons come from your car exhaust fumes in particular. So car exhaust fumes contain a lot of unburnt hydrocarbons. So these are basically the remnants of the petrol which are not burnt. Okay, now unburnt hydrocarbons, when they are expelled through the car exhaust, they form photochemical smog. Okay, it's called photochemical because these unburnt hydrocarbons react in the presence of light to form a type of smog. Smog means it's smoke plus fog. That means it reduces visibility, okay, and it's smoky. Now, this photochemical smog causes lung and eye irritation and breathing difficulties. Okay. Now, finally, we have ozone. Now, the chemical formula of ozone, I would like you to take down. Ozone is O3. So, ozone is interesting because it's actually oxygen. It's an element, right? It's an element. It's oxygen. So, oxygen has two allotropes. There's O2, which is what you breathe in order for aerobic respiration to happen. But there's also ozone, O3. So ozone is an allotrope of oxygen. Just like how graphite and diamond are allotropes of carbon. Okay? Now, ozone can be produced when nitrogen dioxide reacts with unburnt hydrocarbons. Okay? So ozone itself can be produced man-made when nitrogen dioxide, NO2, reacts with unburnt hydrocarbons. Now, ozone is not nice to have at surface level. That means at ground level, when you have a lot of ozone, it causes eye and respiratory tract infections. So respiratory tract means your nose, your windpipes, your bronchi, your lungs. It can also cause chest pains and headaches. And ozone actually slows down photosynthesis in plants, which of course results in the plants dying. Okay? So ozone is not a nice gas to have when it's at surface or ground level. Okay? Now, these are the 6 pollutants that you need to know in your syllabus. Notice how carbon dioxide, CO2, is not in the list of 6 pollutants. This is because carbon dioxide, generally speaking, is not considered a pollutant per se. Carbon dioxide is actually useful in some ways. That's why we don't consider CO2 as a pollutant. Okay? However, of course, as with everything, too much of something is no good. So too much CO2 has started to cause problems for us, in particular global warming and climate change. Okay? So we have finished the very content-heavy page 5. and sure you have taken down all of the notes. Now let's move on to page 6, where we will end the video at page 6. Now page 6 takes a closer look at what is acid rain. Now acid rain, as stated in the title here, it's a big problem. It's a big problem caused by SO2, NO2, and also NO. Alright, now first, there is actually a mistake in the first sentence, right? Only SO2 and NO2 are acidic oxides. Okay, so please cross out the first sentence. Only SO2 and NO2 are acidic oxides. And why are they acidic? Because they are non-metal oxides. Then what about NO? We just said just now, NO is neutral. But it still produces NO2 when oxidized in air. So nonetheless, NO still contributes to acid rain, not directly, but indirectly when it's oxidized to NO2 in air. Okay? And because SO2 and NO2 are acidic oxides, they can react and dissolve in rainwater to form acid rain. Now, just a bit of trivia. Clean rainwater, if the rainwater is clean, is actually slightly acidic still. The reason is because naturally speaking, naturally speaking, there is carbon dioxide in the air, right? There's 0.03 to 0.04% of air is CO2. Carbon dioxide is also acidic, it's non-metal oxide. So carbon dioxide can react and dissolve in rainwater to form carbonic acid, which is H2CO3. Carbonic acid is a weak acid, therefore the pH is about 5. So actually clean rainwater is slightly acidic, about pH 5 to 6, okay? However, if there is SO2 and NO2, it forms acid rain because it reacts and dissolves in rainwater and it lowers the pH to below 4. So it's very, very much more acidic. At this very low pH, it will corrode limestone and metal. Why limestone? Why metal? First, limestone is calcium carbonate. Now think, what do you learn under acids and bases? Are there reactions involving carbonates? Oh yes, there is, right? You have learned that acid react with carbonate. Acid plus carbonate, right? How about metal? Do you learn reactions involving metals and acids? Yes, acid plus metal can also react. So what does this mean? It means that the acid rain will corrode and damage the limestone, which is carbonate, and metal structures over time. Besides that, they also harm aquatic life and plants. So now, let's look at this box below to see the equations which describe the formation of acid rain. You must know the equations. So the first equation is involving SO2. So SO2 can react and dissolve in rainwater to form sulfurous acid, H2SO3. So it forms H2SO3 first. Then H2SO3, sulfurous acid, is oxidized in air to form H2SO4, sulfuric acid. You need to be able to write these equations. So this explains to you why sulfur dioxide can form acid rain. The last equation here explains to you how nitrogen dioxide can form acid rain. Nitrogen dioxide is able to react and dissolve in rainwater to form nitric acid. Now this is a very complicated equation, as you can see. 4NO2 plus 2H2O plus O2 forms 4HNO3. Not only is this complicated, this is actually redox as well. How do you know it's redox? First, you can see it involves oxygen, right? It gained oxygen. That's a very clear-cut sign. But besides that, if you were to calculate the oxidation state of nitrogen, at the start, nitrogen in NO2 has a +4 oxidation state. How about HNO3? If you work out the oxidation state of nitrogen in HNO3, nitrogen has a +5 oxidation state. So you can tell from this equation that NO2 is oxidized as the oxidation state of nitrogen increases from +4 in NO2 to +5 in HNO3. Then what's reduced? The oxygen at the start is O2, it's an element. If it's an element, the oxidation state is 0 by definition. At the end, however, the oxygen is -2. Just like in all compounds, most compounds of oxygen have an oxidation state of oxygen as -2. So O2 is reduced as the oxidation state of oxygen decreases from 0 in O2 to -2 in HNO3. So you can see this is redox, the third reaction here. The second reaction is also redox, but I think it's quite clear-cut why that's redox. I would like to challenge all of us. Can you try to explain why equation number 2 is also redox? Okay? Finally, equation number 1 is not redox. Again, I would like to challenge everyone, go work out why is equation number 1 not redox. Okay? So that concludes the 3 equations that explain to us how SO2 and NO2 can form acid rain. So now let's move on to the very last part, which is the harmful effects of acid rain. Acid rain can damage buildings, particularly, you must mention in your answer, it corrodes limestone and marble buildings, because limestone and marble both contain calcium carbonate, and metal structures. So metal bridges, limestone statues will all be damaged by acid rain. Okay? Now the damage happens over time. So over time, these things could weaken and one day they could just suddenly collapse, which of course is very dangerous, right? Imagine the metal bridges suddenly collapse. That would be quite devastating. Next, acid rain also has a harmful effect on soils and plants because acid rain leaches nutrients. The word leach here means the nutrients are lost. It causes nutrients to be lost from soil. Okay? In addition, the acid rain also reacts with aluminium hydroxide to produce Al3 plus ions. Al3 plus ions are toxic to plants. Okay, you must be wondering, where on earth does aluminium hydroxide come from, right? Most soil has aluminium hydroxide because aluminium hydroxide is present as clay. Clay contains a lot of aluminium oxide and aluminium hydroxide. That's why if there's acid rain, it will react with it to form Al3 plus ions, which will be toxic to the plants. Now, these Al3 plus ions that I'm referring to are aqueous Al3 plus ions. If it's aluminium hydroxide, it's a solid. Solids are safe. It's the ions which are toxic to the plants because ions, which are aqueous, can be absorbed into the plant cells through the root hair cells. Okay, finally, acid rain lowers the pH of lakes and oceans to below 4, which is too acidic for aquatic life to survive. So the fishes will all die. The plants, aquatic plants, will also die when the pH is lower than 5 actually. So if it's below 4, definitely the fishes and plants, it's too acidic for them to survive, they will die. Okay, so you need to know the harmful effects of acid rain as well. So in this particular lecture, we have covered 6 types of atmospheric pollutants on page 5. The focus is on learning the sources and effects of the pollutants. On page 6, we delve deep into this problem of acid rain. How does it form? Being able to write the equations for the formation of acid rain. And also to describe the harmful effects of acid rain on limestone, marble, metal, on soils and plants, on aquatic life. Alright? Again, it's a lot of content, so I would like you to slowly watch this video again if you are in doubt and really to learn the content well. In our next lecture, we shall look at how we can combat these air pollution problems. So stay tuned for the next lecture and see you in the next lecture. Thank you.